Hello everyone and welcome to the lecture on Amazon WorkSpaces. So this lecture will contain all these topics. What is Amazon WorkSpaces? WorkSpaces architecture, protocol supported, configure VPC for WorkSpaces. So what is Amazon WorkSpaces? Amazon WorkSpaces allows you to create virtual desktop using Microsoft Windows, Amazon Linux or Ubuntu Linux, eliminating the need for physical hardware. Users can select from Windows, Amazon Linux or Ubuntu Linux operating systems for their virtual desktops. WorkSpaces support various OS operating system options to meet diverse user requirements. WorkSpaces provides a consistent desktop experience, allowing users to resume work from where they left off. Users can access their workspaces from multiple devices and web browsers, providing flexibility and convenience. WorkSpaces offers both monthly and hourly billing options, giving users flexibility in choosing the most cost-effective plan. You create a standalone managed directory or connect to your on-premises directory for seamless access using existing credentials. For Windows desktops, users can bring their own licenses or purchase applications from the AWS Marketplace. WorkSpaces includes multi-factor authentication (MFA) for additional security and AWS Key Management Service (KMS) to encrypt data at rest, disk in I/O and volume snapshots. Administrators can control which IP addresses are allowed to access workspaces, adding an extra layer of security. So workspaces architecture. So first is VPC and directory association. Each workspace, Windows and Linux, is linked to a virtual private cloud VPC and a directory for storing user and workspace information. So some AWS directory service options are: first one, Simple AD, which is a managed directory service for smaller workloads. Then AD connector, which allows use of existing on-premises Active Directory. And finally AWS managed Microsoft AD, which is a fully managed Microsoft Active Directory in the AWS cloud. Talking about authentication process. So user access methods. Users access workspaces via client applications on supported devices or web browsers for Windows workspaces. And credential verifications. Users log in with their directory credentials. Login info is sent to an authentication gateway, which forwards traffic to the directory for verification. And then streaming initiation. After successful authentication, streaming traffic is initiated through the streaming gateway. Talking about network configuration. So some client application ports. You have HTTPS port 443, which is used for authentication and session related information. Then you have PC over IP, PCOIP protocol, which runs on port 4172, and Windows streaming protocol 4195, which is used for pixel streaming and network health checks. And again, network configuration for workspace network interfaces. So you have management and streaming interface, which is called as ETH0, which is used for management. So here in the diagram, you can see this is for management of workspaces. And then you have primary network interface, which is ETH1, which has the VPC provided IP address. It uses directory subnets. It ensures easy traffic flow and access to VPC resources controlled by security groups. So this is the one wherein this is used for connecting to your workspace, which is the virtual desktop. So it will go through ET1, and this will have all the security group IP addresses, subnets information. And next, talking about the protocols. Amazon WorkSpaces supports two protocols. First one is PC over IP, PCOIP, and second is WSP, which is Workspaces Streaming Protocol. So I just want to correct myself. It's not Windows Streaming Protocol, it's Workspaces Streaming Protocol. The choice of protocol depends on factors such as user devices, operating systems, network conditions, and Windows video support requirements. To use WSP, specific minimum host agent versions are required for different operating systems. Windows requires version 2.0.312 or above, and Ubuntu needs 2.10501 or higher, and Amazon Linux requires version 2.0.596 or above. Okay, WSP also has some minimum client requirements, and the Windows native client version must be version 5.10329 or higher, and while the macOS client needs to be version 550 or higher, and web access is also supported for WSP. So this is the client which you install on your other computer. So these are the some requirements. So you can access it through web browser or through some macOS or native client, similar to what we have seen, like the remote desktop client and all. Okay, WSP is recommended when users access their workspaces across global distances or use unreliable networks, as it offers higher loss and latency tolerance to support these conditions. Okay, use WSP. So if users need to authenticate with smart cards or use smart cards in session, WSP is the preferred protocol. WSP is the choice when webcam support capabilities are required during workspaces session. PCOIP is recommended when using iPad or Android Linux clients, or when using TerraDC Zero client devices. If GPU based bundles like Graphics G4DN, Graphics Pro G4DN, Graphics or Graphics Pro are needed, or if a Linux bundle is required for non-smart card issues, PCOIP is the preferred protocol. PCOIP is also recommended when using workspaces in the China region. So so most of the time WSP should suffice your needs, but PCOIP will be used in a few scenarios, but they will be less than, so it's like 10-20% compared to WSP. Okay, configure VPC for workspaces. So VPC is a bit important because that's where your virtual desktops will be running, and users will be accessing those virtual desktop. There are some requirements on how to configure it. So Amazon Workspaces instances are deployed within a virtual private cloud, which provides a secure and isolated network environment for the virtual desktops. One configuration option is to create a VPC with 2 private subnets for your workspaces and a NAT gateway in a public subnet, and this setup ensures that your workspaces have secure access to the internet through the NAT gateway while remaining isolated from direct public access. So something like this. So you have private subnet and you have public subnet. So they will be routing traffic from here to the public subnet, and through the NAT gateway they can connect. So this is one scenario. And alternatively, you can create a VPC with 2 public subnets for your workspaces and associate a public IP address or elastic IP address with each workspace. This configuration allows direct internet access to your workspaces. So second configuration is here. So you have just direct public subnet and you assign up elastic IP or public IP, and you direct access it via internet gateway. When configuring your VPC for workspaces, it's crucial to ensure that your subnets reside in different availability zones within the region where you are launching workspaces. Availability zones are distinct locations engineered to be isolated from failures in other zones, providing high availability and fault tolerance for your applications. Each subnet must be entirely within one availability zone and cannot span multiple zones. If you use AWS Directory Service to create an AWS managed Microsoft AD or a simple AD, it is recommended to configure your VPC with 1 public subnet and 2 private subnets. Configure your directory to launch your workspaces in the private subnets and set up a NAT gateway in the public subnet to provide internet access to the workspaces in the private subnets. When using public subnets for your workspaces, you need to configure your directory to either automatically assign elastic IP addresses to each workspace or manually assign an elastic IP address to each workspace. This configuration ensures that your workspaces have direct internet access when deployed in public subnets. So elastic IP address is basically a public IP address which you have to assign when they are part of public subnet, when your workspace space is launched in a public subnet. So in that situation, you must assign them manually or automatically. And that's all. Thanks for watching.